Hello again, and welcome to part 3 of the bacteria series. I'm going to start today with a little bit of review just to see where we are. Hopefully you can, at this point, have these things memorized, but bacteria, remember, are what kind of cell? The answer would be prokaryotic cell. And what is the characteristic of prokaryotic cells? They have no membrane-bound organelles. They have that circular DNA. They have the nucleoid region where the DNA is found, and they tend to be smaller. So last talk we learned about plasmids. Plasmids are those extra genomic DNA that ends up in the bacteria cell through different methods. We talked about transduction, where that virus accidentally puts bacteria DNA into the bacteria cell instead of viral DNA. Transformation, where that bacteria cell could just pick up the DNA from its surroundings. Conjugation, where you have the bacteria cells transferring DNA directly to each other. And then we talked briefly about different energies and how they can use it in or make it rather, photoautotrophs, heteroautotrophs, chemoautotrophs, etc. The oxygen requirements for bacteria run the gamut. You've got the obligate anaerobes, the obligate aerobes, and the facultative anaerobes. And then binary fission is how bacteria cells reproduce. All right, so today we're going to talk about some new things, another aspect of bacteria cell classification, and some other different things about bacteria cells. Let the fun begin, right? All right, first off, not in your book, but interesting, cell wall types can be, for bacteria, can essentially be broken down into two different types. You have your gram-positive cell gram-positive cells and your gram-negative cells. This has to do with the cell wall type, and virtually all bacteria can be classified as either being gram-positive or gram-negative. And when bacteria classification, if you have some unknown bacterial illness, one of the first things they will do is, in identifying it, is do a gram stain. And what they do is they get the bacteria that they're looking for, put it on a microscope slide, add a little bit of violet dye, and then wash it away, and then add a little bit of red dye, and then wash that away. And those that are gram-positive will retain this dark, nice purple color, and that's due to a much thicker cell wall than the gram-negative cells. All right, and that thickness of the cell wall is made up of a molecule called peptidoglycan, right, this protein and carbohydrate combination. And it's this thickness that allows this violet dye to stick, and when it's rinsed, it doesn't rinse away, almost like a permanent marker. The gram-negative cells have much thinner cell walls, still made of the same substance, peptidoglycan. But when the purple dye reaches the cell, it only here briefly, and then when you rinse it off, rinse it away, it washes away, and then when the red dye comes in, it stays. So this is again the first thing they do when identifying bacteria cells, trying to figure out what they are, is gram-positive and gram-negative. On a side note, if you can find a bacterial identification book, it's kind of fascinating to look through. If it's downtime being at home, they find one of those books, just flip through it, find all sorts of bacteria. Maybe you can start self-diagnosing yourself. Who knows? Good times. But again, purple, positive, and red is negative. I'd say pink, but that would be too many P's, I suppose. All right, moving on. Let's get the show on the road. All right, endospores. Some bacteria can live in environments that are not hospitable. We did talk about archaebacteria. It's a little different. These bacteria, like anthrax is one of these things that can form a spore. So if they're in an environment, particularly without water, something that's environmentally stressful, the cell essentially dehydrates itself, and what you're left with is this hard kind of shell that's really enclosing the DNA. and making sure the DNA doesn't get destroyed. Then when the conditions are all right, when there's water or nutrients or whatever it's missing, the cell will then reform into the mother cell. The mother cell forms, and the bacteria cell can go on doing what it does, living whatever process it does. I found this particularly interesting. Just a picture I assume is a microscopic image of a bacterial endospore. And it looks like here you have kind of the DNA part, and here's the endospore. It's hard to tell without perspective on the rest of the cell and how small it actually is, but these endospores can sometimes survive high temperatures as well. So if you cool it down, it can reactivate or whatnot. So be careful. Endospores could be everywhere. Now we have how bacteria can hurt us. Right, these harmful effects. Most bacteria cells are going to hurt you through toxins. Often this toxin is not it's not there to hurt you necessarily. It's just a waste product. I'm sure bacteria cells are more scared of you than you are them. They're just going about doing their business, and this toxin is released by the bacteria cell, and it's going to cause you to be harmed. That harm can be anywhere from causing a neuron to be not fired, a neuron overfiring. It could be a toxin that's causing your intestines to fill with fluid, causing you to have massive diarrhea. Many different toxins. The next talk, I'm going to be talking about different types of bacteria and what they do to us. We'll talk more details about the cool things these toxins can do. I suppose it's cool if you don't have it. And then the other thing, septic shock or sepsis. I've been learning a lot more about this lately. I always thought sepsis was when you have too many bacteria cells in your blood and that's kind of clogging things up and you end up dying. But that's not what it actually is. Sepsis and septic shock can happen with any type of infection, whether it be bacterial or viral. Part of the problem with coronavirus, the ones the breathing issues, but in part that's due to sepsis and the flu. Often, if you die from the flu, it's due to sepsis and septic shock. And what's happening is the immune system is being called to a certain area, a certain location, and it's overreacting, almost like an allergic reaction, an over response to something, and this causes massive inflammation and possible organ failure, and that leads ultimately to your death. In the coronavirus, I was reading about it causing the blood and fluid to be leaking into the lungs due to your immune response. It's overreaction. Again, very much like an allergic or reaction like anaphylactic shock. So those are the two ways. And this septic shock can lead to cell destruction. Like tuberculosis is good at calling the immune cells and getting them to overreact. And the final thing I want to talk about today, you're almost off the hook, don't worry, is the bacterial growth rate. It's always interests me. I wish we were in the classroom and I would draw an hour by hour counting of how it works. And you can even change this from day to hour. You start with one cell, and within 6 hours, if you're doubling or division happens once an hour, you end up with many. And with unlimited nutrients and space and conditions are just right. Bacteria growth can be exponential. And if you start with one cell, normally an infection is more than one cell. But if you just start with one cell and it divides once every hour, within 24 hours you have 17 million bacteria cells from that one cell. And every hour thereafter it divides. Now bacterial division and growth varies from bacteria cell to bacteria cell. I don't know that there's one standard rate, but it can be very quickly. And that's why you can go from feeling great to really under the weather in just a couple hours. You're at this threshold of bacterial growth and the immune response just starting, but it can happen very quickly. Anyway, that's look at this. I have like 3 slides, and I think it's going to be 5 minutes, but It's now 10 minutes, and I'm still talking. Well, that's all I have for today. Tomorrow, like I said, we're going to talk more about specific bacterial diseases and what they do and the effects they cause. Enjoy your day. Oh, don't forget to subscribe and like. I need 1,000 subscribers so I can monetize this channel. Let's get it rolling.